Okay, so welcome to the modeling tutorial for your CNC router workshop. In order to get started with this one, the first thing we want to do is go to the D2L course site, go to Content, and go down to Workshops, CNC Router, and you'll find a 3DM file in here with the name CNC Router 2D Contours. Go ahead and download that file. And then when it's ready, you want to open that up. And I'm just going to open it in this Rhino right here. Okay. So you should all have been given a number when you started on the first day in this group, and you'll see that there are 24 different tiles in the group. So based on the number that you were assigned, you can go ahead and keep that number and delete everything else that's in this file. So I'm just going to choose one. I'll choose 18. And you can select it and type invert in the command line and just delete everything else. Okay. So what we have here is a 2D pattern of contours. And you can see that they're all labeled with a different number. So what this is a full-scale representation of a topography, and the numbers correspond to the height of each contour. So what we want to do is, in order to model this thing in 3D, we need to actually move these contours up in the z-axis or in the z-dimension and get them kind of into the position they would be to form a surface. I'm also going to go ahead and hide my grid layer and my dimension layer just to keep it simple. Okay. So what I want to do is I want to select all the contours at the same time, and then I'm actually going to move them up incrementally one by one. Now you can see that the lowest number that you'll find on any one of these tiles is actually 9, I believe. So I think most of the tiles will have a 9, if not it'll be a 10 or an 11. But what you want to do is leave that, move the whole group of contours up to the increment of that first number. So for example, since mine is 9, I'm going to go ahead and type the move command. I'm going to hit V, enter, to constrain the movement to the z-axis, and then I'll snap to somewhere on my contours, and I'm going to enter 9 in the command line and press enter. Okay, so now we've moved it up in 3D space so that it's in the right position relative to like the 0 in our file. And that'll be important in order to get the depth of these tiles right when we actually go to cut them on the router and so on. What we want to do next basically is one at a time. I'm going to deselect each level of my set of contours. This may be easier to see in top view. And then I'm going to move them up by one increment, right? So the next increment up is 10. So I would go move, vertical, snap, type 1 into the command line, and press enter. And now I would go in and deselect all the contours that are marked as 10. And you can choose to move the labels as well if you want. That won't be too important once we've got everything in position. So it looks like there's no more 10, so I would move it again. Move, vertical, 1, enter. And I'm just going to do this for each set of contours. Oops. Okay, and if you look in the right hand side, in the right viewport in my 3D view, you can see that what's happening is I'm starting to get these at the right heights, right, in 3D. And so I'm just going through. I think I actually messed up there. And just do them one at a time. If you miss any, it's no big deal. You can just go back at the end and match them up to what they belong with. Okay, and then if we go ahead and orbit around in our 3D view, and if we line it up right on the side, you should be able to pretty easily tell whether there are gaps anywhere. So just kind of spin it around and see if you have any weird gaps or anything like that. So I missed a contour over here somewhere, and I guess I actually moved this up a little too far. So I can just go ahead and grab all these guys, or I'm sorry, just this one, and move it back down. So move, vertical, -1. Okay. I'm going to go ahead and turn off my labels now as well. So that looks like it's just about where we want it. Oh, I missed this one as well. And the next thing we need to do in order to make this you know, like into a surface that we can build a model from would be to actually create a surface interpolated through these three-dimensional contour lines. So what we're going to do for this, it's really simple. We're going to use the command patch. So if I type in patch, it'll ask me, are there points, curves, etc. that I want to interpolate a surface through, or fit a surface through. So I would go ahead and select all my contour lines, press enter, and you'll see a little dialog box open like this one. And if I click on preview, it'll actually give me some idea of what that surface is going to be like once I've created it from these lines. Now, what's happening right now is because the patch command can see that I have a closed surface, it's automatically trimming my surface to that like lowest closed outline. So if I just go over here and uncheck automatic trim, and I'll click preview again, there we go. So that's what we want. We want a loose surface that's going all the way through our geometry. Now we could keep this these settings like this. There's a couple of things you can do that make it a little bit more precise in terms of how closely the surface fits to the contours. So we're going to do those things. We'll go up to sample point spacing, change that to 0.1, and so that basically means like that's how far apart the sample points where it's testing how close the surface is to your contours. That's how far apart those are. The next thing is the U and V spans, and that means the number of subdivisions in your surface. In other words, the level of resolution that your surface will have. So I'm going to change that to a higher number, 40. And then the stiffness usually is fine, left on 1. And now I can click OK. And if I orbit around it, you'll see, and let me just change the color of this real quick. I'll make a new layer, just so we can see the lines a little better. But as we orbit around it, we should see very little of this, where the lines start to kind of disappear. If you have a lot of that, that means that your surface isn't fit very well to the curves. But you can see it's pretty clean, so we have a good surface here. So that's the three-dimensional topography surface. What we also want to do now would be to trim that surface. So I'm going to go over to the layers and turn the grid layer back on. And you can see that little square that defines the extents of our topography is down there. I'm going to go ahead and extrude that. Extrude, curve. And I'll just change my current layer to the surface layer. Doesn't matter if it's closed or open, I just want to extrude it all the way through that surface. I can delete the curve, and then I'm going to go ahead and trim these two objects and join them together. So if I select both at the same time, type trim, I can trim the box, I can trim the excess topography, and then when I'm done I'll just type in join, or I'm sorry, press enter to finish the trim command, then press join. And then we have one closed topography surface modeled, and the base is going to be important for the steps that I show you next. So this would be the right way to model your topography at full scale. You can see in our file that we're in inches, and if I were to measure this little tile, you can see it's actually pretty large. It's about 100 foot square piece of topography right there. So what I want to do next, before I get into developing this geometry for something that I might make a physical model of, in this case a CNC routed model of, what I would want to do next is scale it. So I'm going to go ahead and actually delete or hide the original contours at this point. So I don't need those contours anymore since I have this surface. And I'm going to change the units of my file first. So I would type in units in the command line, press enter, and then we want to go ahead and change the model units to feet, or I'm sorry, inches, from feet into inches. Click OK. Now it's going to ask you if you want to scale it. You want to hit yes. Now my Rhino cam opened. I can close that real quick. Okay, and then if I zoom out, the position of your object might have changed relative to the 0. But that's because what happened is, because we scaled it, this object, even though my file is in inches, is actually the same size. So now if I measure the distance of it, you can see it's about 1,000 inches. In other words, 96 feet. So in order to go down to the scale I need it to make a model of it, and let's say the scale we're going to use here is 1/16 of an inch equals a foot. And what I'm going to do is scale it. So I type scale in the command line, choose a corner point, and first I want to scale it from feet into inches. So I'll type 1 divided by 12, 1/12. Press enter, and now you can see if we measure the distance again, we just scaled from feet to inches. So now our tile is 96 inches by 96 inches. And then we would actually scale it to the exact scale that we're using for our physical model. So again, I'll type in scale, click on one of the corners, and enter 1 divided by 16. Okay, and you should be left, if we measure the tile now, with a 6-inch cube, meaning that it would be 6 inches in height and width, or length and width. Okay. So now we have the tile that we want, and it's at the scale that we want. Before I do anything else, I'm actually going to move this to the origin of the file, which is something that we'll use later when we go to do our Rhino cam setup. So I'm going to type in move, click snap to the bottom corner, and just enter 0, 0 in the command line. Okay, and now we're back at the origin of the file. And what we actually want to do is to generate a stepped topography file. something like what you would do if you were going to make a laser cut model, or just some, a kind of representation of a topography. So all I got to do in order to create a new set of steps for my topography surface is to contour this geometry. So what I'm going to do is make a new layer called 3D contours. Set that to my current layer. I might also change the color. Okay. And then with my object selected, I will type in contour in the command line. The first thing it'll ask you for is a base point. We want that at the very bottom of our geometry. So I'll snap to that one of the bottom corners. Then it'll ask you for a direction perpendicular to the contour planes. Meaning if we want horizontal planes cut through this object, we need to draw a line that's vertical. And again, I can just use my geometry. I'll snap to the top corner of whatever corner you started at. And then the next thing it will ask you is for the height of those contours, or the distance between them. And for this, I'm going to use 1/8 of an inch, 0.125. And then I pressed enter, and now you can see I have, not only do I have the contour lines, but because I joined my surface with the box, or I trimmed it and joined it to the box, so that I have this base, each one of these outlines, even the ones that are on the outside edge of the surface, are closed. And what's great about that is now we can just type extrude curve, and we can extrude each one to 1/8 of an inch as well, 0.125. And then we would get our stepped contour 3D model. And before I go any further, I also want to actually, I extruded all these curves up from where they intersect my 3D surface. What I want to do is actually go ahead and move the 3D contours back down again, so that the leading edge is kind of intersecting my surface. So I could go ahead and type SEL select last. Select last will allow you to select all the objects that were created or used in the previous command. So again, I'll type move, vertical, snap to the top of one of these contours, and then snap to the bottom. So that's what I was talking about. I want the outside edge of those contours to be hitting the 3D surface. And I can just delete the bottom one. Okay, so now we have our stepped model and our 3D model. I'm going to go ahead and turn off the 3D surface model. The very last thing that we want to do is actually create a box around this model, because we're going to cut this thing on the CNC router. And what we're actually going to do is cut like a form in order to pour concrete into that form. So first I'll create a box. Just type box in the command line. Oops. Oh. Type box, press enter, and then I'll hit 0, 0. Now we need to make a box that's slightly larger than our tile, so that when we cut this geometry out of the box, we'll have some walls projecting above it. So I'm going to make it 7.5 by 7.5. And the material we're actually going to cut this out of will be 2 inches deep. So I'll type 2, and there's our box. Now what we'd also want to do at this point is center our geometry in the middle of our box. So I'm going to go into wireframe. I want to move the contours over so that the midpoints are touching. I could also move it by 3/4 of an inch, 3 by 4, which is half the extra size of this box. And then, so now, even though our 3D contours are centered inside our box, We also want to go ahead and make a void in this box, which is where we're going to cut into. So I'm going to make another box. This time I'll just snap to my geometry, and then I'll snap to the height of my of the first box that I drew. Okay. Now if I go into shaded, you'll see I have two boxes, and all I need to do is Boolean difference. So it'll say polysurfaces to subtract from. That's our first box. Press enter, subtract with. That's our second box. And there we go. So that's the geometry that we'll use in the next part of this assignment when we actually set up our RhinoCam file for CNC routing. So I'm going to end this video here, and then there will be a separate video to do the RhinoCam setup.